Good morning, guys! Today, we are going to solve linear equations using the inverse of a matrix method. In our previous video discussion, we have used the Gauss-Jordan method in solving a system of linear equations. Okay, so suppose we are given 3x plus 2y plus 2z minus 1 and 5x minus 3y plus 4z equals negative 3 and 2x plus y plus 2z equals negative 2. So we're going to get the coefficients. So the coefficients are 3, 5, and 2. We also have positive 2, negative 3, and 1, and 2, 4, and 2. So unlike the Gauss-Jordan method, we are not going to copy this yet. So instead, we are going to write the identity matrix. Okay, so we have 1, 0, 0, 0, 1, 0, and 0, 0, 1. So our goal is to make this area here the identity matrix. So that's 1, 0, 0, 0, 1, 0, and 0, 0, 1. So we will follow the same procedure in the Gauss-Jordan method, wherein we write particular rules to follow in order to come up with this matrix. But on the other hand, this side should have quantities other than 1 and 0. Okay, so to start with, we must make our first column, first row, or first row, first column be equal to 1, and we can only do that if we multiply row 1 by 1/3. And so let's do that. So all we have to do first is copy rows 2 and 3. Okay, so rows 2 and 3 are here. Then divide 3 by 3 or multiply 3 by 1/3. So you have 1, 2 by 1/3, you have 2/3, 2 by 1/3, you have 2/3, 1 by 1/3, and then 1/3, 0 by 1/3 is 0, and 0 by 1/3 is 0. So this is now our new augmented matrix. Okay, now our goal now in the next step is to make this equal to 0 as well as this one. So we can make this equal to 0 by multiplying our row 1 by negative 5 and add it up to row 2. Okay, so we have that already here, negative 5r1 plus r2. Then we can make this equal to 0 by multiplying negative 2 to our row 1 and add it up to our row 3. Okay, so we have negative 2r1 plus r3. So since we're going to deal with rows 2 and 3, then we may now copy the first row. So the first row here is copied. And then what we're going to do now is, obviously, this would become 0. So zeros already. And then 2/3 will be multiplied by negative 5. And then added to negative 3. Okay, so we have negative 2/3 by negative 5 minus 3. Okay, let's use another color. So we have negative 5 times 2/3 minus 3. That would be negative 10 over 3 minus 9 over 3. I hope you remember, you can remember your operations of fractions. So negative 10 minus 9 is negative 19 over 3. Okay, so that will be the value here. Next is negative 5 times 2/3 plus 4. So that's it. Negative 5 times 2/3 plus 4, which is equal to 2/3. So kindly review your operations of fractions. So we have here 2/3 as our answer. Okay, then next is 0. Okay, so we have negative 5 times 1/3 plus 0. So negative 5 plus 1/3 plus 0 is negative 5 over 3, which is this one. Okay, so since we don't have any other values here other than 0, so you just bring down 0, 1, and 0. Okay, then let's proceed to row 3, negative 2r1 plus r3. so that we have negative 2 of 2/3 plus 1. So negative 2 of 2/3 plus 1 is equal to 1/3. Okay, negative 1/3. So that's because we have negative 4/3 plus 3 over 3, which is negative 1/3. So kindly review your operations of fractions. Alright, so we have a negative 2 of 2/3 plus 2. So negative 2 of 2/3 plus 2 is negative 4/3 plus 6 over 3, which is equal to 2/3. Okay, then we have negative 2 of 1/3 plus 0. So that's equal to negative 2 of 1/3 plus 0 is negative 2/3. Okay, and since those are zeros, so you may copy this. So you have 0 and 1. Okay, so we're done there. So the next thing that we are going to do is to make negative 19 over 3 as well as the other elements in that row to be equal to, to be multiplied by negative 3 over 19. We multiply this row by negative, or row 2 by negative 3 over 19 because we want this to be equal to 1. So all you have to do now is copy rows 1 and 3. So we have rows 1 and 3, and then 0, and then that's negative 19 over 3 times negative 3 over 19 is 1. Negative 3 over 19 times 2/3 is negative 2 over 19. Negative 3 over 19 times negative 5 over 3 is 5 over 19. And negative 3 over 19 times 1 is negative 3 over 19. And negative 3 over 19 times 0 is, of course, 0. So again, just recall or review your operations of fractions. Specifically here, multiplication of fractions. Okay, so since this is already 1, then let's make this 2 be equal to 0. So how are we going to do that? Then let's follow the following rules. So we multiply negative 1 here by the reciprocal additive, alright? The additive inverse of 2/3. So that's 1 times negative 2/3 plus 2/3 to make it 0. So we have that already, negative 2/3 R2 plus R1. Then after which, we multiply 1 by the additive inverse of negative 1/3, which is 1/3 plus row 3 to make that equal to 0. So the rule is 1/3 R2 plus R3. Okay, so we are going to copy first row 2. So row 2 is copied here. And then we are now going to use this rule, negative 2/3 R2 plus R1. So negative 2/3 multiplied by negative 2 over 19 plus 2/3. Okay, negative 2/3 times negative 2 over 19 plus 2/3. Okay, so that's positive 4 over 57, and so that's 2. So 19 times 2 is 38 over 57. So you have 42 over 57. When simplified is equal to 14 over 19. Okay, so you have that here. Then next is, okay, multiply 5 over 19 by negative 2/3 plus 1/3. Okay, so negative 2/3 times 5 over 19 plus 1/3. That's negative 10 over 57. And 19 times 1 is 19 over 57. So you have negative 10 plus 19 is 9 over 57, which is simplified into 3 over 19. So you have here 3 over 19. Okay, next is multiply negative 2/3 by negative 3 over 19 plus 0. So negative 2/3 plus multiplied by negative 3 over 19 plus 0 is positive 6 over 57, which is 2 over 19 when simplified. Okay, now since this is 0, so it's not a problem. So the output here is going to be 0. Okay, let's proceed to row 3. So the formula for row 3 again is 1/3 R2 plus R3. So 1/3 times negative 2 over 19 plus 2/3. 1/3 times negative 2 over 19 plus 2/3 is negative 2 over 57 plus 19 times 2 is 38 over 57. 38 minus 2 is 36 over 57, which is 12 over 19 when simplified. Okay? Then we have, that was again 1/3. 1/3 times 5 over 19 minus 2/3. So you have 1/3 times 5 over 19 minus 2/3 is 5 over 57. 19 times 2 is 38 over 57. So 5 minus 38 is negative 33 over 57, which is negative 11 over 19 when simplified. Okay? Then we have, that was again 1/3. So 1/3 times negative 3 over 19 plus 0. So that is 1/3 times negative 3 over 19 plus 0, which is cancelled. So you have negative 1 over 19. Now, as you can see, this is 0. So, multiplied by any number is equal to 0. Then plus 1. The result is 1. Okay. So, let's proceed to the third column. So, first is we are going to make this equal to 1 by multiplying it by its multiplicative inverse, which is 19 over 12. So that our rule is 19 over 12 R3. Okay, or 19 over 12 times row 3. So since that's multiplied by its multiplicative inverse, so the result is 1. And then by the way, you have to copy first rows 1 and 2 so that you can proceed with row 3. Alright, so negative 11 over 19 times 19 over 12 is equal to negative 11 over 12. Negative 1 over 19 times 19 over 12 is equal to negative 1 over 12. And 1 times 19 over 12 is equal to 19 over 12. Okay, so we're done with row 3. So our problem now is these two. We are going to make these two equal to 0 by following some rules again. So we multiply 1 by the additive inverse of 14 over 19, which is negative 14 over 19, and added to row 1 to make this equal to 0. And so that's with the other elements here. Then multiply 1 by 2 over 19 plus 2 over negative 2 over 19 to make this equal to 0, as well as with the other elements here in row 2. Okay, so the formulas now are negative 14 over 19 R3 plus R1 and 2 over 19 R3 plus R2. So let's start with R1. So again, write down first your row 3. So for row 1, we have, these are now equal to 0 because that was our aim, right? So for row 1, we have negative 14 over 19. So negative 14 over 19 times negative 11 over 12 plus 3 over 19. So negative 14 over 19 times negative 11 over 12 plus 3 over 19. So you can cancel this so that you have 7 and 6. And so you have 77 over 114 plus 6 times 3 is 18 over 114. So 77 plus 18 is 95 over 114, which is 5 over 6 when simplified. Okay, so let's proceed. Again, that's negative 14 over 19 by negative 1 over 12 plus 2 over 19. So negative 14 over 19 times negative 1 over 12 plus 2 over 19. So cancelled again, so you have 7 and 6. Then this becomes 7 over 114, and 6 times 2 is for 12 over 114. So 7 plus 12 is equal to 19 over 114, which is equal to 1 over 6 when simplified. Alright, so let's go back. So you have negative 14 over 19 times 19 over 12 plus 0. So you have negative 14 over 19 plus 19 over 12 plus 0. So it's cancelled. This one is also cancelled. So we have negative 7 over 6. Okay, so we're done with row 1. Let us now proceed with row 2. Okay, so the rule is 2 over 19 R3 plus R2. So 2 over 19 multiplied by negative 11 over 12 plus 5 over 19. So 2 over 19 times negative 11 over 12 plus 5 over 19. That's cancelled. So you have negative 11 over 114. Then 6 times 5 is 30 over 114. Negative 11 plus 30 is 19 over 114, which is 1 over 6 when simplified. Okay. Then we have 2 over 19 again, multiplied by negative 1 over 12 plus or minus negative 3 over 19. So we have here 2 over 19 times negative 1 over 12 minus 3 over 19. So cancelled. So you have negative 1 over 114 minus 6 times 3, negative 18 over 114. Negative 1 minus 18 is negative 19 over 114, which is negative 1 over 6 when simplified. Then the last for this row, that's positive 2 over 19 multiplied by 19 over 12 plus 0. So that's 2 over 19 times 19 over 12 plus 0. That's cancelled. So you have 1 over 6. So 1 over 6. All right. So we have seen that we already we have come up with the identity matrix already, right? So we have 1, 0, 0, 0, 1, 0, 0, 0, 1. So that means these are our elements of the inverse matrix. So A inverse is equal to 5 over 6, 1 over 6, negative 7 over 6, 1 over 6, negative 1 over 6, 1 over 6, negative 11 over 12, negative 1 over 12, and 19 over 12. Now, after that, because that is not yet the final answer, because we are looking for the values of x, y, and z respectively, then we are going to multiply that inverse by the matrix obtained from here. So at the start, I told you that we are going to use this later. Okay, so that's it. So we are going to multiply. We are going to do matrix multiplication here, so that 5 over 6 times negative 1 plus 1 6 times negative 3 and negative 7 over 6 times negative 2. So you remember your multiplication of matrices. Then we also have 1 6 times negative 1, negative 1 6 times negative 3, 1 6 times negative 2. Okay? Then negative 11 over 12 times negative 1 plus negative 1 over 12 times negative 3 plus 19 over 12 times negative 2. So as you can see, this is a 3 by 3 matrix. This is a 3 by 1 matrix. So the outcome would be a 3 by 1 matrix. So let's simplify this. So this will be negative 5 over 6 minus 3 over 6 plus 14 over 6, this one. So that we have negative 8. I did not simplify it yet because I would like to see to it that they have the same denominators so that it would be easier to add. So we have negative 5 minus 3, negative 8 plus 14 is 6 divided by 6. We have 1. Then, also, in the second row, negative 1 plus 3, 2 minus 2 is 0. So you have 0 divided by 6 is 0. And finally, we have row 3, that's 11 plus 3, 14 minus 38. And that would be negative 24 divided by 12, which is negative 2. Therefore, x is equal to 1, y is equal to 0, and c is equal to negative 2. So that is how we obtain the values of x, y, and z using the inverse matrix, okay, method in solving. Okay, so that's the end. That's quite long, right? And tedious. All right. So I hope you learned something today. This is Dr. Batukan saying mathematics is easy to learn when one learns with enthusiasm. Bye.